So this presentation is about the products and the services that will be used for a specific use case defined for Tunisia, which is the wheat crop growth condition, phenology, and related water stress in Tunisia. And I will co-present it with my colleague Giovanni Laneve. So let me where is the view? I just need to change a little bit. Well, should be okay. So I will first introduce the service portfolio and the use cases quickly, and present then the specific use case that we will focus on, and describe in more details the different relevant products and services that will be included in this specific use case. Okay. So this is a service portfolio prepared by the Africultures team. As well, we had a chance during a previous workshop to present more in detail all the product list. Mainly we have 7 services, as mentioned earlier by Juan and Evans, and we they include different products at different resolutions from high to coarse, and we will focus for this case study mainly on crop services and crop products. So after some co-design work with Tunisian, with the consortium team and the Tunisian partners, there were preliminary use cases that were defined for Tunisia, and they are well, 4 use cases were proposed, which are the wheat crop growth condition, phenology, and related water stress, the irrigated areas crop water use and need estimate, the drought monitoring and early warning, and the crop acreage and yield estimate. So we decided during this workshop to focus on the first one and the third one that will be presented later on by Vasilis, which are the more mature ones, and to get first feedback from you on that. So regarding the specific use case, the motivational challenge behind it is that, as said earlier by Evans, wheat is a key crop, considered as a key crop, and the cereal production is around more than 8% basically from the agricultural production. And there is an increasing demand for wheat cereal mainly production, and the food security. In order to reach it, all stakeholders and involved decision makers, they need relevant information and timely information on the growth and state of crops, so that they can act timely in case of drought or pest or disease. So we built a user story from which we could start with as having a technical team interacting with farmers and willing to get relevant information on crop growth conditions, phenology, and related water stress. So this is a scenario that we try to work on, in particular for wheat, and the aim is that to select from the Africultures services and products the relevant ones, and the geospatial data and tools that can be used in Tunisia or specific areas, and can help for the monitoring of the crop growth and the status of crop development. So among the products that are proposed for this user story are the crop type mapping, the crop condition monitoring, the crop phenology monitoring, and the crop early warning. So I will go more into details with these products. Considering the crop condition monitoring, it involves 4 indicators, including the NDVI and the LAI, the leaf area index, which are used for monitoring the greenness of vegetation and the density of the canopy, while the vegetation condition index and the NDVI anomaly are anomaly indices based on the NDVI and comparing the actual NDVI measurements or estimates to long-term estimates of NDVI. So in one case, the mean is used. In the other case, the minimum and maximum values are used. So this is basically the difference. Regarding the medium resolution for these products, we use data from MODIS and Copernicus with a spatial resolution of 250 meter in one case, 300 meter in the other case. The time resolution is from 8 to 10 days. And in the case of Copernicus, there are usually the time series that we provide are from 2017 to the actual date, which is basically the duration of the project. For the medium resolution products. In the case of Copernicus, there were a separate data set because of a change in the provision of the data, and there was a change in the source of the data, the satellite used for producing the data. There was a switch from the Probavi to the Sentinel-3 source of data. So there are 2 data sets basically available earlier than mid-2020 and past mid-2020. Here is an example of some map of NDVI at medium resolution again over the northwestern part of Tunisia. For a date in May in 2020, and here are some time series these are screenshots from the platform of Africultures, so we can visualize for a specific spot. So here it's one field visited during the field survey in Jedduba by our partner, the OSS, and other colleagues in February 2019. So we can display and visualize the variation over time of some of these indices for a specific location. And during the presentation of the platform, the demo later on, you will see more functionalities like this one. So I will give the word to my colleague Giovanni so that he goes on with the other products related to this use case. Please, Giovanni.
Yeah, thank you, Ines. I will ask you to go on with the presentation, so with the slide. Okay. So
this one, sorry.
No, that one is okay. This one is okay. So as Ines said, for some of the products, we are providing them at different spatial resolution. In particular, for the one related to crop, they are we have medium and high resolution. The high resolution products are based on the Sentinel-2. Then, for instance, we are providing this crop type mapping at 10 meter spatial resolution. This is actually, I have to say that these crop maps are provided for Tunisia only on one of these, the presented here area, then in particular the Jedduba governorate. Is already provided for the full country for Rwanda and for other countries in Kenya and South Africa. But of course, the area will be extended in the next weeks or on months. Of course, for now, we have developed the procedure that we think is good enough to mapping the crop types in the area of interest. This is just an example of one of these crop maps done based on Sentinel-2. We are using actually the phenology, then the temporal series of Sentinel-2 images in order to map the different type of crops. And we can see also, of course, in order to do this, we are exploiting the ground truth data provided by our colleagues from Tunisia. Because, of course, in order to proceed with this mapping, with this classification, actually, we need, of course, ground data. Okay, you can go on the next one. Concerning the phenology monitoring in the platform, you will find two type of maps as before at medium and higher resolution. This is an example of the one at medium resolution that you can find there. For instance, this is the comparison between the phenology in Tunisia for years 2010 and 2020. This was taken from the FAO Vapor website. Then, of course, in our platform, you will find products provided or developed by us, as well products coming from other sources. So I think it will be useful to find everything all together in the single platform. So this is a comparison between, as I said before, the phenology in 10 years of difference from Tunisia. We will see there is, as you can see, there is a lot of change, mostly in the central eastern part of the country. You can go to the next one, please. Move on to. Okay, this is the case of at high resolution. In the left side is this sort of actually is a RGB map produced using the start of season NDVI maximum, then the day of maximum NDVI at the end of season. This was done actually for the a county in South Africa, the Free State County. And on the other side, then this was the phenology. On the right side, we see the monitoring of the phenology. Then the estimate of the delay or advance in the NDVI value in a particular field. In this particular case, values are going for -4 to 4. That number should be multiplied for 10. Then the red areas are areas where the crop is in delay of 40 days with respect to the phenology, expected phenology for that particular area. On the other side, the green parts are corresponding to areas crop where or fields where the crop seems to be in anticipating the season with respect to the phenology given for or expected for that particular area, that particular crop. Please, Ines, you can go on the next one. The next one. Concerning the crop early warning, this is also this one is provided at two different level. I mean, the medium and high resolution is based on using the VCI that was already introduced by Ines, then the vegetation condition index. What we call it the TAI, that is the temperature anomaly index, and also the precipitation anomaly index. These anomalies are computed comparing the actual values of temperature and also precipitation and vegetation with the expected value coming from the average of the previous, in case of meteorological data, 10 years. So for any decade of the year, we have estimated the maximum value, the minimum value of the temperature of, for instance, precipitation. And then based on that, we are providing this crop early warning. The crop early warning is composed of actually 4 levels. Then we assume that the level 1 means when we can find a low value of the NDVI, just a low value of NDVI. It becomes 2 when together with the lower level of NDVI, we found also, for instance, a high level of the temperature, then an anomaly in the temperature. It becomes 4 when all of them are together. I mean, when it's present an anomaly in the vegetation, in the NDVI, an anomaly in the temperature, and an anomaly in the precipitation. Then you can go on the next one, to the next one slide. Okay, this is an example of this product. It was actually, I put this one concerning the Ethiopia because was the one showing more differences, more evidences in the presence of the anomaly in the crop conditions. Then here on the right side is almost described the characteristics of this kind of product. Is of course in a GeoTIFF format, then it's georeferenced. Then you can put everywhere on your own GIS system. Is provided every 8 days because it's based on weather data provided by our partners and satellite data coming from MODIS. And the different level of warning are given, described here. Okay, Ines, please proceed.
Sorry, this one.
The next one. Okay, this is the case of the high resolution. We have actually not found an example for Tunisia. We found this, you see the circle here, the blue circle around this red area. This red area is an area in which, according with our approach, we found an early warning at level 1, then just an NDVI anomaly in the vegetation. But as you can see, it almost seems to be in Algeria, not in Tunisia, just at the border. But okay. I've added this, just this. In order to, we assume that the anomaly in the NDVI is there if we found the anomaly for 3 times, then in 3 consecutive images. Then this means that in order to come out with this information, we need 10 days, because if I assume at 0 image 1, after 5 days, we have the second, the Sentinel-2 image, and after 10 days, we have the third one. If the same conditions, I mean, the anomaly is present in all of them, we issue this, we come out with this warning. Okay, can go to the next, if there is, okay. This is almost.
Thank you, Giovanni. This was the last slide.